Hello learner, welcome once again to Manifested e-learning platform. My name is James Kenyani. Yet again we are continuing with our lesson on reflection and congruence. So in the last lesson we looked at reflection in the y-axis. Today's lesson we are going to look at reflection in the line y is equal to x. Reflection. So the lesson. At the end of the lesson, the learner should be able to deduce or get the images of points or objects on reflecting in the line y is equal to x. So as that goes, you should deduce that, but there is someone asking, where is that line y is equal to x? In the Cartesian plane, we have that line, the x-axis, which is y is 0. We have the vertical axis there, which is the y-axis, x is equal to 0. A line y is equal to 0 is equals to x is a line on the Cartesian plane where the x-coordinate will always be equal to the y-coordinate. So if it is 1, you'll find the x-coordinate will be 1. You come there, if that is 2, learner, that will be 2. The same case here, negative 2, negative 2. Negative 5, negative 5. So if you draw the line, it will have properties. You'll find it will be bisecting that right angle. It will in fact be a bisector of those two right angles. So that is the line. That is the line y is equal to x. Learner, that is the line y is equal to x. Any point on that line, if x is 1, y is 1. If x is 2, y is 2. If x is 3, y is 3. So that is the line y is equal to x. So to get that, we shall reflect some points. You choose some points. So you'll have the image. Sorry, we start with the object. And then we have the image. So our first point, which is acting as the object, we can have 4, 2. We can have another line B, negative 3, 3. Negative 3, 3. We can have another line, point C. We can have another point C, negative 2. Can have 2, negative 3. And the last point, you can choose point D, where we have 4, negative 2. So we shall go to the Cartesian plane. We start with the first point. Our first point A is 4, 2. You come here 4 and 2. 4, 2 is there. That is our point A. You check very carefully. So from the properties of reflection, the point will be direct at a distance equal behind the mirror as the object is in front. And the line joining the object to the image will strike the mirror line or the reflecting line at 90 degrees. So you move. Let's move and see. So you look very well. This point you'll get A prime is somewhere here. A prime, let's check. So you'll find A prime, A prime will be 2, 2, 4. You come and get 2, 4. So that is our A prime. Now you start noticing what is happening. 2. What has happened? The coordinates seem to be interchanging. The coordinates seem to be interchanging. Let's move to the second point, which is the object is given as -3, 3. We move -3, 3. -3, 3 somewhere there. -3, 3. So that is B. So you try and drop some distance behind. So you try and check. You look very well. That distance, if you take it the same, you end it at B prime. What you notice for B prime, it is 3, -3. 3, -3. At that point, you tend to see what is happening in the coordinates. They interchange. The coordinates are interchanging. The x now becomes the y. Let's move to C. 2, -3. 2, -3. That is C. 2, -3. You'll actually come and have -3, 2. And it's even now able to deduce that. But let's see what will happen. D, 4, -2. Same distance behind the mirror as that. So we have 4, -2. D prime, you'll have -2, 4. So what do you notice? We notice that if we have a reflection in the line y is equals to x, in the objects, the coordinates of x and y interchange. On reflecting, in the line, not line, in the line y is equals to x, the image is B, A, the coordinates x and y coordinates interchange. They interchange, e.g., if we have the object and the image, for example, if we have 2, 2, 2, 4, the image will be 4, 2. If we have 3, -9, the image will be -9, 3. That's what actually happens. But notice that some of coordinates appear on that line. So we have coordinates that appear on the reflecting line, appearing, that would remain the same, appearing on the line are 0, 0, 1, 1, 2, 2, 3, 3, -2, -2, etc. So if you have, those are the points that appear on the reflecting line, which means when you reflect, they'll remain on the line. The image will be at the same position as the object. The image will be at the same position as the object. So if I had 3, 3 here, it will still remain 3, 3. So at that juncture, you'll work out in the assignment, I say find the images of the following. So for the assignment, you'll work out that, and before we just summarize, notice what has happened. This is the line y is equals to x. It is a line where the x coordinate on the line and the y coordinate are always equal. We also notice that on reflecting a point, an object on that line, the images of the coordinates, if we had 4, 2, the image will be 2, 4. If you had -3, 3, -3, 3, the image is 3, -3. The x and the y coordinate interchange. That helps us to easily deduce the images, the coordinates of the images under such a reflection. For example, if I have 20, -20, the answer will be -20, 20. If I have 3, 5, the answer becomes 5, 3. That is a characteristics of images reflected in the line y is equals to x. The coordinates just interchange. So at that point, our objective of finding that has easily been met. And as usual, find a good example by laying that on the Cartesian plane in your graph book. So at that juncture, I close the lesson, go through the assignment given, and let's meet in the next lesson. So thank you for your audience, and bye.